to the calculation of the frequency and the wave number of the electrons that is getting jumped from one orbit to another orbit, and thereby the release of the energy. So as we know that according to Bohr's postulate, if electron jumps from a higher orbit to a lower orbit, higher energy orbit to a lower energy orbit, there would be a release of energy, which is amount of h into nu. Nu is the frequency, and according to Bohr's third postulate, h nu is equal to E2 minus E1, where E2 is the energy of the initial orbit from the higher orbit, and E1 is the energy of the lower orbit, right? So now what we see that if we have to calculate the frequency, let's see what would be the frequency. Now, as we already know that energy that we have derived for any atom is given by this. So suppose I have the E2, then this will be 1 by N2 square Z square ME4 by 8 H square epsilon naught, I think epsilon naught square, and E1 is equal to 1 by N1 square Z square M e power 4 8 H square epsilon naught square. So these are the two energy of these two energy level, and now just substituting in the Bohr's formula, that is H nu is equal to E2 minus E1. So we will just take this common, then we will get minus 1 by N2 square plus 1 by N1 square into taking this common, Z square M e power 4 8 H square epsilon naught square, right? Or I can just take this H here, I can write Z square M e power 4 by 8 H cube epsilon naught square, this is nu, is equal to 1 by N1 square minus 1 by N2 square, where N1 is the final orbit, N2 is the initial orbit, right? So here what we are talking about, what is the final orbit and what is the initial orbit. So this is the formula for the frequency that would be released when an electron jumps from one orbit to another orbit. Now coming to the wave number or nu bar is nothing but nu by c. When we divide the frequency by the velocity of light, that is what is the wave number, which is again equal to reciprocal of the wavelength, or the wave, or this is what is wavelength. So when we calculate the wave number, it means actually we are calculating the reciprocal of the wavelength. So here from this we are actually trying to understand what will be the wavelength of this released energy that we are talking about. So to do that, we just need to take this frequency and divide by c. So here we are just taking this Z square M e power 4 by 8 H cube epsilon naught square into c into 1 by N1 square minus 1 by N2 square, right? So this is the wave number, or from this we also get the wavelength of the released energy that we get when an electron jumps from one orbit to another orbit. And from there we will be next understanding what would be the spectrum and what would be various type of wavelength and various type of frequencies that we get when an electron jump from a particular orbit to particular orbit, which is also a kind of signature for an atom, which we will do in when we are doing the spectrum. So therefore this frequency and wavelength is very important when we are trying to analyze the spectrums of such atom using the Bohr's theory. And here we have used actually the third postulates of Bohr.
If you like the video, then press the like button, subscribe to the channel and press the bell icon.